Alright, welcome to this ALP. In this ALP, we're going to use the sum and difference formulas to determine exact values of trig expressions and verify certain trig identities. Now, in order to do that, we have to know what the sum and difference formulas are. So, as you can see, we have them right here. The cosine identity, if cosine of angle A plus angle B, well, then you can use cosine angle A, cosine angle B, minus sine A, sine B. And, oops, gotta switch this sign here. This is supposed to be plus. So when you have a cosine of sum or difference, know that if it's a sum, then it would be the difference of the cosine A, cosine B, the difference of that, and sine A, sine B. And if it's cosine the difference of two angles, then it'll be the sum of these two here. Now looking down at sine, sine is a little bit different. In sine, it's going to be the same. If it's a sum, it's going to be a sum over here. But you do have to switch the angles. So it's going to be sine A plus B equals sine A cosine B plus cosine A sine B. Okay, and if it's the difference, it'll be minus right here. For the tangent identities, once again, looking at that sign in the middle, either the sum or difference, if it's a sum, it's going to be a sum in the numerator and a difference in the denominator for tangent. And for tangent, if it's a difference, it's going to be a difference in the numerator and a sum in the denominator. That's just something that you're just going to have to memorize. Now, in order to prove these identities, I have this picture here. Now, say we have angle A plus angle B, and we want to prove that those identities are true. So, since we have all these different lines, that's going to help us prove this. Now, if we have, since angle A, or not angle A, line AC crosses these perpendicular lines of AD and GH, angles A and AHG, this angle up here in this corner, those angles are the same. That means that angle BHG is the complement of this angle here. And since angle GBH is the complement of that angle, that means it's the same as this angle in here, which is the same as angle A, which is just a really long way of saying angle A is also the same as the measure of the angle up here. Now, the next step in proving these formulas starts with the fact that line FB equals lines EH plus GB. So we're going to come up here to this equation, show line FB equals EH plus GB. Now, if we take each of these and divide it by the value that is line AB, as long as we do it to each part of this equation, it does not change the equation. And lastly, if we multiply part of this equation by AH over AH and part of it by HB over HB, as long as you multiply something and then divide it by the same thing, the value is not changed. So we're going to multiply this fraction, by AH over AH, which is the same as multiplying it by 1. And we're going to multiply this fraction by HB, this line down here, over HB. Now, since we know that the order of that numbers are multiplied does not matter, we can change this denominator to HB and this one to AB. Change this one to AH and this one to AB. Now that we have that all together, we can see that FB over AB, let's see what that is down here. FB is this line right here over AB, and that's the same as the sine of A plus B, because if we added these two angles together, this would be the opposite side, and this would be the hypotenuse. So we're saying that that equals EH over AH, which is EH over AH, which is sine of A, let's see if that matches up here, sine of A, yep, times AH over AB, AH over AB is cosine B, so sine A plus cosine B plus GB over HB equals the cosine of A, because it's the adjacent over the hypotenuse. So let's see if that matches. Yep, cosine A. And then that times HB over AB. HB over AB, which is the opposite. HB is the opposite of this angle B, times the hypotenuse, so it's sine B. Do that. We've proven this, and all we have to do to change that to this minus is just change the signs. Now, to prove the cosine sum and difference formula, we're going to start with the fact that AF equals AE minus GH. Okay, so we'll write that up here. AF equals AE minus GH. Okay, see that all down here. And once again, we can divide this all by AB. And if we divide each of them, it does not change the value of this equation. And now we're going to do the same thing with AH and HB as we did earlier. So multiply this by AH over AH. And multiply this second one by BH over BH, which still does not change the value. And once again, since the order does not matter, change this to a H, change this to a B, change this A, B to BH, and this BH to AB. And that, since the numbers, it does not matter what order you multiply them in, you can switch it around like that. And just like up here, that shows that comes out to this right here. I'm not going to go through that all again because it's a little complicated and takes a while. And once again, to get this difference formula, if you just change this positive b to a negative b, well, the cosine b here isn't going to be affected at all, but the sine b is going to become negative, and subtracting from a negative is the same as adding.